Hello,
Hello
everybody.
everyone. Hello Vishwas.
Hello.
Hello everyone. I'm Supriya, the organizer of Azure Developer Community Varangal. Today we have a session on the Azure with ML. It's good to see you again, Vishwas.
Thank you so much.
Previously we had a session on the same topic, uh, which is on the basics. If you guys have not catch up, please go to our Azure YouTube channel and you can find out there. So, Mr. Vishwas,
Thank you so
please, over to
much.
you.
Yep, I think I'm already sharing my screen. It's already visible for you folks. So I'll be there on my board like this. So exactly as always. So yeah. So I'll always be there on the board. And if you guys have any questions and queries, so please do check it out. And over a course of time, when you think evolution of ML workflows, which are ML plus AI and all these things included, there is always a need for us to optimize compute and optimize operations. So when you think of operations, it's all about the training, testing. It's all about like how can we rapidly deploy models after testing it? Like how can we not go through the hassle of not building such kind of an application which uses all these things, and how can we go ahead with all these processes, right? That's where you always think about like let's just optimize the operations, so that like basically when we are training the model, we train it seamlessly. Then when we are testing the model, we train it seamlessly. Then when we are deploying it, it has to be automatically deployed. It's always like that mindset of being in one click instead of many clicks. There is always a need for you to think like where can you fit in this entire process, right? This is where you prefix this and this with operations. And over a course of time, when you think of a huge set of data set which is already available for you and which is already being targeted for different amount of tasks that you're just going through, I think that there is going to be a lot that you will be realizing for yourself, right? So that is where you always think of like, hey, where can I fit in with all these things? So it's like one click rollback, one click deploy, rollback, and all these processes. So let's say the testing didn't go well. There is already a deployed model. Let it start working. Let it make the money. Then we just roll back to the training part, and then we go ahead with whatever it's required. And seamless working of all these applications will happen there right now. And if you think of a tool like Power BI, I think Power BI, I didn't install that. Let me just go to the marketplace and install the Power BI. So you guys can understand like why is there a requirement of the R? Like, should we really go through the hassles of all these and just move ahead with all these? No. But like, is it worth the what do you call investment? Yes. So it's all about that. Like you still know that okay, there is a fair amount of chance that I will be also be not be getting all the results right. So it's always that that mindset is just going to give you all these. I think there is an example of different plots that has been given here. So I think seamlessly we can start going ahead with all these applications. So I'm showing you why, because all these visualizations has their own effects on the business problem statement that you are going through. So I think it's downloading, it will just get uploaded over a course of time. So even that, we needed some sort of a visualization for all these, right? So how many went out as a successful deployment, how many went out as an unsuccessful deployment? So here we are people, so we are going through that, and I'll run one by one notebooks after one after the other, and I'll show you how. I think let me just run it off, and so that there is no other thing that can go wrong here. I think we'll also talk in terms of the deployment and everything. So let it keep running. So tutorial 2, deploy models. You are here. So I think this will keep running. you need to authenticate the compute, right? Okay, so authenticate. So there was a pop-up after this, and we just ran that, and everything got sorted. So here you go, folks. I'm already running a compute right now, and it's seamlessly working right now. I think I've already successfully authenticated the computer. Yes, it's already taken care by the other processes as well. And also, look at the magic that it's already using Python 3.6, which is required for this version. And also, there is a terminal like this, right? You can go and really make the best use of it. Let's say TensorFlow. Oh, sorry, not this one. So you can do pip list. This is just like a compute attached onto your computer. That's it. So it has everything. Everything has been installed here for you. Like let's test TensorFlow JLMNOPQRST. So TensorFlow is here, folks. So Tensor Board is there, TensorFlow Data Service is there, plugin Vet is there, Tensor Board X is there, TensorFlow is already there, and the latest version has been installed. So if you can see that, this is where that latest installation has happened. So it seamlessly worked for me because it's a cloud computer, right? It can do anything for it. The best that it can deliver. I think it did the best, perfect with whatever the job it did. I think this is okay. I cloned it, right? So it already is there. I think there are some processes which are running. I think we can take care of it later as well. So don't worry about that. So yes, of course, there will be a name for it and everything. I'll be going step by step with it. And look at the magic. I just used that, what do you call, an AutoML experiment. It's already there for me. So I think I can show you another one, which is an AutoML experiment. I can also show you just an raw experiment that we can just create and we can start working. You can also go through any of it. So, right. So let's just create a notebook, or else let's just move ahead step by step. So this is the magic portal. Select your service. I think I'll be doing Azure Databricks, Azure Machine Learning, as well as I'll be showing you some of the demos from my website, so you guys can go check that out. So it still runs the same. Just copy and paste this, all these credentials, and everything will be sorted. So magic icon, create it. So let's create all of this. Just go to the new 1, 2, 3 something, 4, 5. Okay, it already existed. Now it's not. And let's say Vishwas Narayan is here. I think there's a new resource group that I created and the same name but like different one. So I let me just add one here. So one will be given here, right? So right now everything was taken care by Azure. So I just told what's the workspace name. It gave me storage account, key vault, application insight, container registry. If you want, you can add it. If you don't have it, don't worry. You can go ahead. You can just create it on the deployment itself. So I seamlessly created a deployment. And of course, you can run the validation. It just churns out some steps on its own. And now you will be ahead with something like this. So you can launch a studio. So here there is an icon which says launch the studio and everything will be started for you. And there is already a completed experiment here. So let's just click on it and see whether the explainable model is already created. Look at the fact that there is already an explainable model which is created for me, right? There is already a model which is created. So a model is already created for me and everything can be taken care. So this is a seamless way of getting all the things done, right? So now it's a very simple step. Let's just move on with it. I think notebooks have run to some extent. I think we should wait for some more time. I think after the authentication of the compute, everything will be taken care from it. Or else if it's not, we'll just go through the code. So you'll not get all of these. You just get all these things. So just move ahead with it. So everything will be sorted. I think last time we did AutoML. We did the deployments. We just wanted to show you some, but we just wanted to show you how the model can be tested as well. So this is a little quite of an advanced one. So if you are very new to it, just get hold of it. You will be ahead of it. So if you view the explanation of the model, there is going to be an end-to-end step which is going to explain all the things, right? It says that glucose, this much of information was given, and the importance was 0.539. The age of it is 0.23%, 0.23% of it, and 0.126% of it. So, and there are different matrices as well, right? You check out all the different matrices that you have already plotted, and you can see it. And if you want some more, you can really hit on every little things that is there here, and you can get more plots plotted. So I think what is this is an confusion matrix. If you want the normalized ones, you can also do that. So this is something which just happened in front of you, which was supposed to happen on a Power BI dashboard. So Power BI dashboard also behaves the same way. And we'll also see how to connect a compute onto a VS Code. We'll also see how the compute can be optimized here as well. All right. So let me just close this. Power BI is very bad. So wait. We'll slow down my application. So let me just close it. So you guys can see me, right? So is there no lag? So if you guys can see me, that's perfect for me because that's what I want. So you can click on any amount of matrices, it will be there for you. And you can see that, right? Different steps, different cumulative gain curves, everything was taken care here. Just look at that. I just keep adding all these matrices, and there will be some sort of a new graph or else any sort of a change that is going on. So you guys can think of all these normalized curves, everything that is taken care here. All the matrices has been given to you folks. If you want it in the form of a table, yes, you can take it. Look at that. It's in a form of a table, and also in the form of a chat, it's available to you. Also, it is showing me how much of an negative rate, positive rates, everything that happened in this experiment of on this data set is being shown here. So it's a simple way to understand what are the different matrices, what are the application. And also, like, if you can go back and look at all these data transformation was already taken seamlessly, and you need not have to do much of an hard work to get to know, okay, how did this framework entirely do this data transformation. I didn't get the head and the tail of it. Why? There is already this kind of a matrices which is already explaining it. In a similar explanation can be given here, but you know what, it already does that entire job for me. It already creates n number of notebooks. It knows what's the state of that experiment, as well as it knows different matrices. There's test accuracy, f1 score, log losses, value of f1 scores. Everything was taken care. And also models are in the sklearn format. You can still download the models as a pickle file. I'll show you where to download it. So you can see that, right? In that artifactory store. Of course, yes. What you just did was a DevOps thing. You are just storing everything in a form of an artifactory, and you're saying it that there is an ML model code, input examples as the JSON, model pickle, requirements.txt, everything was sorted. So let me just say I just want to test any of it. So I can take this as well. So let's just take this. Okay. So right now, let's just do that. And let's see what's the fate of it. And you can download it as well, it's not a big deal. So if you can click on this, there's model.pickle, and there is already file path which is just saying that it's a database file store. You can download it, simple as that. Look at the magic, I already downloaded the notebook. So let's just keep this for a while, and we'll move on to the testing part and everything. So of course, when you look at the test results, it's just the way in which you are just using the same old notebook, and you are just linking it to the ML flow experiment, and you're just moving ahead with all these. So what's an ML flow? Whatever you did in the ML here uses something called as an experiment. So This is an experiment that you're just going to create, and already it's seamlessly created for me. I can create a new Automl experiment, say this is the compute cluster that I want. I can say this is the notebook that I created, and everything was in predict target, everything was taken care, right? So it took place here. So everything seamlessly was taken care by your experiment that you just wanted to create. So in a similar way, there is something called as an experiment here. So you can click on that and you can just start working towards it. So this is how you always try to get yourself indulged in all these things. And seamless working that just happened. So right now you just clicked on that experiment, you know, you got to know, okay, these are all the matrices, these are all the graphs that I'm getting right now. And what next? You can deploy it as well. And you can also deploy different children's which was taken care. Like this happens when you're in huge data, but this is a simple data, so it didn't happen. So different logs actually was created over a course of time. It said, okay, this is working, this is not working, and everything was taken care seamlessly. All right. So this is where AutoML was taken care even without any sort of a permission. Like it just seamlessly did its own work. It didn't wait for me, it didn't wait for you. It just went on with it. So let's just see the completed experiment. Just let's look for it. Models, experiments, explanation, everything was taken care here. So I need not have to do much. But when you just click on a raw model, like let's say, okay, you wanted to do this, there was something called as data guardrails, right? You know, this is an amazing feature that you can really look forward to in your entire career as a deep learning or a machine learning engineer. What is this data guardrails all about? It just says whether this type of a data is suitable for kinds of an experiment that we are trying to build towards. Like this says that, okay, does this have any sort of a NaN values? Does this require any sort of a featureization? I think last time when we did an experiment, we talked about a lot of featureizations. Like, so this is where you get it. So models are here. Click on it. Coding Ensemble is one of the models. You can download this. Azure doesn't charge you for this. And look at the fact that, you know, I just show it in a folder, show it here, and look at that. You know, there is already a script file which is already running it. Open, which is doing all different sort of an experiment which is required for me, which has the model.pickle and it has an environment information. This is how you require for deployment. And it just did seamlessly. And test the models, you can do it with different clusters as well. But I would say you one simple trick here. Just go to the model. Okay, so there are different models that was already taken care here. So let's just go for this model here, model here. So you can deploy it and you can test it. So it's a very fair and a simple process. Let's just go through that. And I'm choosing ACI, Azure Container Instance. Just choose that. Let's just wait for the endpoint. By the time this creates an endpoint, I'll be explaining you the Databricks. You know why Databricks was an important and a crucial role in terms of your what do you call the experiment that you just wanted to do. I think ML flow example. So this is one of the notebooks that I previously had written. So I will be using the same thing here. So that's what I will be doing. All right, users.gmail.set example. So that's there. So yeah, I think this notebook is working fine for me. Even last time, I think this will work even better for me right now. I think we can go ahead with this. Let's just move on with it. So what is a Databricks expert? So Databricks was always an entity which just started out with its journey as a map reduce, which then got introduced as an Hadoop. And some people said that okay, there's a batch processing done, but people are more towards their real-time processing. Can we really go much more intuitive here? So this is where Databricks came into the picture. In a similar way that you just do here for the Databricks, you do it in a similar way for the machine learning as well. But I'll show you what's the difference here, because whenever you are going to create a compute instance, wherever we are going to create an instance here, there are no hassle of containers, there are no hassle of keyboards or anything, because there is already an Azure Active Directory which is already connecting it. So there's no other thing. But ML is a different story because it will be connecting to different entities. It will be always connecting to some others. Tenant ID will be used, some others, anything can be taken care, right? So this is where your experiment goes a little tough here. So in a similar way, just create a new resource group, or else use the same resource group which is already there. So we'll use that and we'll say Vishwas something. Let's say there is a name of Narayan. So there's already creation which happened, right? Seamlessly this started working, and there are no other hassles of all these things. So let's just go ahead. You just create it, it'll just create, or else just go through this. There will be a new workflow that churns out some processes and then move on with it. And look at the fact that there is nothing like this. But let me just show you what happens in an ML experiment. In an ML experiment, there is already a default path which says that this is where your ML flow tracking URI will be there. And the studio web URL will always be there. If you launch the studio, it will just go here, or else it's just the same thing here. Already a registry was created. Keyword name is already done. Application inside, of course, it's required. So you just connected many of the services without you just wanting to connect to it. Like you just did go and click on it, right? So it just went down here. So ML flow tracking URL, of course, it's here. So you guys can check that out, or else you can just add it on your own thing, or else it will be there. So ML flow is just an experimental entity. That's it. So in Databricks, it's very easy. Click on the sidebar which has this experiment tab, and you'll be going here, and then go to this create auto ML experiment. You will click on that, click on it, choose a compute instance, choose any of the file or any other instance that you want to create. Like, let's say I just wanted to do this, and I just created it. Perfect. And I say I don't want to give any experiment a name right now, so let's not give that. Let's just go ahead and just create something new. So you can create an AutoML experiment. That is what AutoML created, but you can create a blank experiment. So that's what I'll be creating for a notebook here. Let's say Vishwas, artifact location, it's optional, but you can still give it as an optional itself. So artifacts will already be there for you. So if you click on any model, it already goes, right? So this is where you're defining all these. So if you forget it, don't worry about that. So there is already Vishwas here. So just copy this and paste that in that. I'll show you how to do that as well. So don't worry about that. So let's just go to this C8. Click on any of the model that you built. Model will be deployed in terms of an artifact here. So what you just did is in state of the art MLOps experiment without you thinking of an MLOps. But let me just say you one thing. For your AutoML experiment, it requires an instance about 10 ML. का मतलब, go to the compute instance here. It's a simple way. Even for every little thing, you need compute, and compute is so seamlessly attached in here. Like you need not have to go through the hassle of it. So let's say there is always a standard one, there is always a runtime one, but there is always a standard one and an ML one, that a runtime one, what I just was saying. So you can choose a standard one for just simple experiments, or else you can choose ML for heavy experiments which uses a lot of compute cluster. Of course, you can create a new cluster and start working on it. And Databricks unit is a DB unit per hour. It might cost you around like uh, 2.25 hours to 6.75 hours. That's the number of load which has been taken care here, and you can see the magic of this entire infrastructure. So just look at that. So Databricks unit per hour will have 2.25 to 6.75 का मतलब 2 to 8 worker nodes का मतलब 2 to 8 VMs will start working simultaneously. Why Databricks experiments are so easy to build? It's because of that seamless transition of scaling and scaling out is already happening. and 28 to 112 gigs of memory is already available for you. All these artifacts will be stored in that disk only. With respect to that, just look at that, 32 divided by 8. Let's just do this. I think she has calculator, not me. 32 divided by 8, it's 4. 4 cores per every virtual CPUs that will be allocated from 2 to 8 workers will be created. And of course, one driver will have 14 gigs of memory with 4 cores. This is what they are explaining here through a seamless transition between 8 to 38 two cores. So this is what your Databricks unit is, and seamlessly took off. And you just choose the ML and choose 10 and above because that's what is required for your ML workloads. You can choose GPU as well, but GPU is not being supported. So this is where you need to go through Tesla architecture or something. But NVIDIA EULA is not that great. So choose Tesla or else just choose Scala with just in virtual core runs. That will be like awesome. So let's just go to the notebooks and we'll see how they are working. So what I explain here is just a raw ML flow which will be coming in, but lately there is also a new kind of an experiment that is always done in terms of ML. So you guys can take that as well. So right now, let's just go through that one experiment that we just wanted to do. I think it's already being triggered. I think endpoint has already been created. Wait. It should at least show me healthy, unhealthy, or else some sort of a thing. But why didn't it come up? So, yo, man. Unhealthy. I explained so much and it's taking so much of time to deploy. Is my subscription available? That's the biggest question. It's active. Oh, yeah, it's active. So, my subscription status is active, folks. So, it's active. Why? Deployment logs. Of course, there is no endpoint created, so there can't be deployment. But it will happen. We'll do that testing as well, so don't worry about that. So, yes. So it's simple. Just go create in that way. So you're already good with the AutoML. And now you can go to the machine learning. You can create a new notebook, or else better, I'll just go through a regular workflow and we can go on with creating one. So you can create a new one notebook. I say Vishwas and it's Python already, and it's just really worked for me. It's a simple thing. Just go ahead, copy and paste this. Of course, there will be an error. There is no error already. There were since I already installed an ML while a compute instance, so there is no requirement for ML flow. But if you just go through that normal installation wala thing, just click on the compute, click on that compute instance that you just selected, and go to that, and there is something called as libraries. Click on it. So install a new, yes, and you can install any number of artifacts, any number of clusters that is required by your side. So if I click ML flow 1, 2, 3, 4, something like let me just do that. This will not get installed, or if there is an optional repository thing that also you can do, but I don't think so. But you can do that, and there'll be a new installation that will be happening. So it's a simple move. Just do that, you'll be sorted for the rest of your life. So let's just go there and just run that. And this is the most crucial part. Sometimes when you forget to set the experiment will not run, right? So what's happening here is also the same thing. All the models have been generated, all the models have been created. It's just that simple step about putting down to that experiment. So what it's just doing is it just takes the model and look at the fact that when you just put in all the details and the matrices, the data transformation, the test results that you really wanted to take care. So let's see what is this experiment giving. So there is always a job which is running and which is saying you have to fall in terms of an ML flow model, right? So there you have it. all the different experiments that you started conducting just fell down here, and all the different matrices were already taken care. Different matrices, different runs, all of things were being sorted. And look at that. You seamlessly had an experiment that was already created for you. So it's a simple move. I just do this. But look at the fact that this will not be there. What you have to do is go to the experiment section here and you will be sorted. So this is an experiment section. Just go click on it and you will be sorted. So it's a Vishwas here, right? So what I do is I just click on it. I just go to my workspace, click on Vishwas. All right, why is it not working? So workspace. Let's just go there. Let's just go here and yep. Nay, 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 nay. Let's just go to my workspace. All right. Why does it come not come? So it's simple. I just go here, copy this, and paste the new one. Look at the magic. Now it seamlessly works. And it's saying that MLflow owner's email is this and MLflow owner ID is this. And perfect. You just created that experiment wala thing. So you can do that on your local system as well, but it takes a pretty much more of a configuration. You can induce an Docker workflow and you can start working. But I think when there is already something that you're already paying, why do you have to worry about it? Just go pay a little bit more money, you're sorted for the rest of your life. So it's always that, like, ML flow is giving you that seamless transition into that IT infrastructure. Just go ahead and just use it. And I would love to do this because sometimes some Databricks workflows doesn't come out seamlessly for me. Sometimes it doesn't start working and all these things. So I just do this pip install CLI, Databricks CLI, and upgrading it will just give you all the Python interpreter, which will be restarting it, and every other process will be taken care here. And now let's just go ahead and load the data set. Simple public data set is already available for me. Why should I always do all different hassles, right? Simple as that. Just go ahead and run it. So data sets are here. ML flow experiments was already set. I don't think so. This will be set again. And now I do this run and it seamlessly started working. In a similar way, I do all these kind of monkey nonsense in the machine learning. So just go do it. So this is not a low code and a no code thing. So just move ahead with anything that you really want to do work towards. So yeah, if I do df.head in pandas, PD df.head is basically giving you first 5 data sets, right? In the first 5 rows and all the columns. Rows are like this. Columns. So first 5 columns will be given to you. So it's a simple thing. All rows will be given to you and everything will be sorted. In terms of annotation, of course, they are going to be different in every different places, but this is seamlessly working, folks. Of course, I hate this ML nonsense, but I love it sometimes. Let's just do it. I think this website will be up. I forgot the name of it. Databricks by Vishwas.web.app. Web.app. I think this is the one. You go to the notebooks. That notebook will be there in this website. So just go click on it. So you guys will be there. And yeah, I think, what was this? Yeah, this is my previous one. So it was just for the beginners. So don't worry about that. So advanced one will be taken care of here. So I know this is a pretty advanced one, but sorry for that. You guys will get bored if I do too basics again. So I had to do it. So just go and click on this, folks. It's just so seamlessly working for me. It'll seamlessly work for you as well. Just go click on it. And there you have it. There are different matrices that were taken care. Like X-train data was already taken care, X-test data was already taken care, all the data sets and annotations were taken care, the linear model was also taken care about, and different matrices were also considered about training. So lasso LRS, lasso regressions, and everything was taken care here. And you can see that it already got stored in that ML flow experiment, and there is already a source which is saying that okay, this guy already did a notebook and it's already working fine. And there you have it. See that this is where your ML flow comes into the picture, and you can get your GitHub linked, and there is a personal access token and everything for that, so we can go that. But look at the magic that already all the experiments which said that okay, you just get all the different matrices, but there was no model which was generated. So all different matrices were taken care here, but no model was being generated because I've not gone to that step, right? So it's already there, it knows its process. And now let's just click on the new process, and you will be here right now. And see the magic. It seamlessly is doing it for me. It's just storing all the artifacts in your experiments here. So if I just go here, click on Vishwas, and of course there is no refresh happening because I didn't do anything much here. And now look at the magic of it. There are different experiments. Let's refresh it. Look at it. There are no different matrices that were taken place, and different matrices didn't affect it as well. So there are different versions after versions that have been taken care, right? So let's just click on something called as a source here, and you will be amazed by what has really happened. What really got that matrix is already going through green. So all the green text was already taken care here. I think I can show you that GitHub wala thing. Don't worry about that. We can go ahead with all these things. So let's just do all these different experiments, all these things. So let's just Control C, Control V for a while. Oh, I think there will be a new ML flow experiment that is already being created. Worst thing to happen. I wondered. Oh, right. There is already no compute called as logger, right? So let's say what is the Spark UI saying for me? Spark UI is just an entity which just says you what is happening in your entire Spark cluster. Okay, there was all the runs which happened. Every information is there in front of you right now. How many processes got killed? That is also there in front of you, and everything is seamlessly there in front of you. So okay, so there were 82 jobs that was run. Ka matlab there were different notebooks that was ran, and everything was sorted here. And okay, so let me just go to the compute. Let's say libraries, and I say logger, logger. I think that was the name of it. So let's see what was the name of it. It's logger, right? logger. What did I put in? Install libraries. All right, it's installing. That's perfect. It's simple steps for it, so it doesn't take too much of a time. I think if we just rerun this is going to be there. Perfect. Of course, there is already logger which is already being installed. That's cool. And of course, there are simple ML flow experiments in sklearn. So I'm just using sklearn here, and everything was taken care here. So received command C. Perfect. This is working cool. And let's just click on it. All right. It's working fine now. So let's just click on all the data set. All right. So this is good. All right. See that, I just did a run which didn't happen. And also this got to know that, okay, there was this changes which happened here, and everything was done here. Like this is the best part about having an DevOps thing in your mindset when you're just doing your software engineering. So this is the best thing. I think everything was being loaded, everything was taken care here. auto log, predictions, everything will be taken care. And now see the magic of it. It will just get stored and artifacted in your location itself. So if I do refresh, perfect. There was already a model which was generated. Everything about that artifact seamlessly came in front of me. I didn't do much. It already came here. This is what you call the state of the art MLOps, right? Databricks already has that. So I think probably if somebody is trying to do too much of a work on all these things, just say them, just use ML flow, everything will be sorted for you. I think Kubeflow is a little bit of an headache, but ML flow is pretty amazing, by the way. Let's see whether the plots will be stored and everything. So just keep a look at this experiment. There was already an ML run which happened. And now look at this. Complete information about this entire run is in front of you, right? All the logs, everything was taken care here. And let's just refresh it and look at it. There was already one more matrix that was already being created. That was your image. And you can see that there are different matrices that was already created here. There are different tags which were already taken place. Of course, the plot, what you have here is already saved here. So this is what the entire advanced ML scenario is, right? It's all about like how can you save everything as an artifact in one place and you can move ahead with it. So this is where everything comes into the picture. And I think so. I can show you this as well. So I think I showed you pretty much everything about the ML ops here. I think there's nothing much left here. I think sorted. And see the magic. Right now, I just click refresh, and 7 seconds ago, there is a new ML source file that's already being generated. And look at this. Oh, everything as a plot is in front of you, right? This to me is a state of the art MLOps. This to me, what I just showed to you is the state of the MLOps with all the geo redundancy and the data redundancy taken care into the consideration. Nothing was left. Everything about the feature engineering of a data set, about plotting the data sets on a real-time dashboard and presenting it, everything was taken care seamlessly here. So let's just do some more and let's just plot some more graphs and things like that so that you will get to know how is all these things sorted in the real-time production environment and things like that. So there's PySpark SQL that I'm using right now here. So PySpark SQL is now being used and you can start working on all these. So let's just click on it. So you guys have it. Let's just click on it. You will have a different set of experiments that will be coming right now. Oh, sorry. I think I ran it again. Whoa, file store. Let's see whether the Prima India dataset will be there. Oh yeah, because I use the same data set for again, so I think probably this is going to be the best thing. So I think that was there in that file store. It's still there. It's very simple, even if you don't get it, just go to that data, click on it, and there's already a path which can be created. And look at it. You already have a file store which is already having different set of data sets and everything was taken care here. So you can get to know the history of this data set, whether you deleted any of the entities, what was the information that was taken care here. Everything will be taken care, people. It's just little bit of presence of mind. Everything is sorted. And see, you can also do EDA here. You need not have to work on any other things. Perfect. I think let's just go ahead. Let's just do all the other applications that we are going through, and we can go ahead. Training.spark. All right. If I do training.show, it's just that same old data set which comes up. So, of course, pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function. I don't know about that, but you guys can research about that. But I've used outputs here, but I've also used pedigree function because it's a regression value, right? So you need not have to do much. Okay, based on all these learning, just do regression. So that's what I did. Sometimes you can do ML without any sense. That's not a problem. And look at it. You can really print the schema, right? I'll be doing that for you right now. So database schema takes a huge pain, and now you are having everything in your hand. And look at it, there is a root repository which has all these different matrices, and what kind of a data set is there in it. Everything was taken care. And I think this is the best, and you can see what are the columns which are there. Columns is always the consideration that you do, so you guys can do that and look at it. Now I'm just doing sort of an algorithmish approach for different things. So I think there are different features that were being considered. Everything that might go wrong was also taken care here. I think from is what I missed. And I think this started working. Perfect. Oh, I didn't select that. So we can go ahead and we can start running everything. Output.show. It's already there. So feature ensembler is basically which is going to do the feature enhancement in one function. So what do you
Sorry to
have as
interrupt
an
you, Vishwas here,
yeah?
but am I audible? If I am
Hey, you are
audible, your
audible.
voice is not coming.
Oh, you are audible. Is my voice now available?
No, your voice is not coming.
All right. So can you hear me now? Now can you hear me?
No, your voice is not coming.
Wait, I'll just
Hear your
rejoin again.
voice,
Don't worry about it.
Way are
Vishwas.
you able to hear?
Yeah, I can hear his voice.
He can hear his voice. She can hear his voice. She can hear my voice, right?
Yeah, I can hear you. I'm listening to you from the beginning.
Yeah. Can you hear
I
me
think we
now?
had a problem. Yeah, it is still audible.
Yeah.
Yeah,
Then,
I
arey,
think
my
he has a
voice is
problem.
audible. My
I'm sorry.
voice is audible. Okay. If I speak here, my bajuwala auntie can hear that. Got it?
I'm
Don't
sorry.
worry
I'm
about
sorry.
that. Like I'm like, how come my voice? My voice, man. I'm in full flow. Okay, don't. Okay, fine. Let's come to the point. So output.show is one thing that you just did right now, which is just going to show you. Okay, after feature enhancement, what is the big deal? Just show me all the different matrices. Okay, you can see that, right? Now, there are different ways that you just saw. Okay, this is what the input was, and the outputs was also considered like this itself. And of course, when you just click on the entire application, you can see how many changes happened, how many rows happened, and all these things. There are different ways that you can gauge that. So analytics folks, you guys can come and do all the session, not me, by the way. I'm not an analytic folk, by the way. So it's all different columns, rows, everything that was considered, and finalizing that is what I'm doing here. So finalized data outputs were being considered, and I think this is the best part about all these things, right? you know like it's an end-to-end solution for getting to know what is your data set, what are the insights from the model that you're going to deploy, and there you have it. Finalized output will be there, and you can see that there are different individual features that was considered, and the diabetic pedigree function is in the double data set, and you can see that, right? This is where you don't have to do too much of an analysis in the real time, but you can just go ahead, just draw in all these functions from the documentation, and you can start working. So this is where it starts working. And of course, finalized outputs can be shown. That means that how many features were being considered right now and how many matrices were being considered. And right now, you just saw that there is an independent feature that was being considered here, and of course there are diabetic pedigree function. So this, to me, what I just wanted to do was just a line fitting between the two given points. How can I get some value out of it? This is a pedigree function that I've chosen right now. So this is what I did. And let's just do the machine learning nonsense. And yeah, I think this should start working. You can see that different data were being considered, and now what you just have is an end-to-end. solution for the data that you just wanted to get. I think it's still running. The matrices have already gone to the experiment. All right. Let's see. All right. There is already a notebook that has been generated. The source has already been given. It has been versioned already. So you can save that. The models were being generated. Different matrices were already taken. And look at the fact that it was a class that was used. I used ensemble, linear regression was used, random forest was used at one given point of time. And PySpark linear regression was being used, right? And now this came to an end. And you can see that I used the Spark instance at one point of time, right? You can see that I started using the Spark instance here. And of course, Spark data source was already being considered here and it's just being metriced out. And look at it. There are different ways that you can get your Spark instances up and running. This is where you can easily do it. You don't have to do that hassle of installing all the things. And of course, it's also intelligent, by the way, and it's giving me some sort of a notification and saying that you have an auto logging created from the MLflow run. Hyperparameters will be always be taken care, and this is what you see, right? The parameters, hyperparameters that was being considered are all kept here. So alpha sometime was considered as 0.1. Alpha 1 is just a new metric to say what was the alpha that I just had it, and here you have it. So different matrices, man, different matrices can be considered right now, and everything will be taken care seamlessly by an ML flow experiment. All right, so let's just do this. So to the advanced folks who thinks that okay, there are different ways you can enter an ML infrastructure, here you have it. Databricks, AutoML, Designer, notebooks in your entire infrastructure can be used. Of course, I think I wanted to show you some sort of a notebooks, but whatever I'm explaining here is what being done here as well. So that's why I didn't want to waste your time by explaining two of these notebooks and everything. So I'm just by doing my one notebook that I had, I'm just doing it. So let's just do a little bit of another experiment. So okay, so there is a linear regression that has been considered. So let's just look at that first. So I think finalized output was already considered, and I think there are diabetic pedigree function that is considered again. Of course, there are different training that is happening. There you have it, folks. Different trainings were already being considered. Of course, what are the different coefficients were being considered? Everything can be all metric out here, so you guys can check that. I think there are coefficients that have been computed right now. So let's just copy some more intercepts. What's an intercept? It's just going to be an interpretation of all the different matrices that you're considering, and it's just saying what can be the relation that can be learned. And there you have it. Pedigree results are here. I think all the X-train, Y-test, Y-train, X-test, all the things were now being taken considered, and all these jobs which were having different workflows and everything were now taken here. And see the magic, whatever was being succeeded came out as succeeded, and all the non-killed versions and everything was taken. Of course, there are different ways that you can run an experiment and look at what are the different models. Spark model is already there, sklearn model is already there. If you can click on it, you get all the artifacts about it, and see that there is a requirement.txt considering MLflow, PySpark, SciPy, and in the sklearn there is a different requirement.txt itself. So I think when you go for this, click on the requirements.txt, look at this. Scikit-learn, typing extensions. I think there should have been something called as a job lab, but I think as soon as you install this scikit-learn version, it's going to give you that thing. So I think that's a fair move that was done by Databricks right now. I think that's perfect. So pedigree results are now being considered. The results will be shown now. So crucial. All right. So different predictions were taken. The diabetic prediction function was 189, but it's 307. I don't think so. This is a better model, but all the artifacts will be stored in the experiments here. So you guys can check this out. Refresh this, and you can see that there are different Spark models and everything. Different matrices that were taken. Loading more, it's impossible, but now it started churning out different insights. Of course, last time when I ran these experiments, they were very close to each other, but I don't know why this time it's so bad. Yeah, that's the fate of ML. Can't rely on them every time. So that's the fate of it. And of course, there are different ways that you can visualize this entire data set. So look at this. You can go here, click on this. This is the best icon. Like you can just go for the different plot options which are there. You go for the area plots which is there here. Map can also be done, but map is not there for the this one. But this is for a global data. I think pie charts can also be taken care of here, right? So just see that, right? No, even though I just gave a very sparse data which is in this range, it already came in here as a pie chart. And I think legacy charts are always there. So line chart can also be done. Everything, folks, everything can be downloaded. I think when you just seamlessly go here and check out on all these different features that are there in this entire plot and everything, you can do that. Of course, I can show you in the Power BI. I think probably it will be a too much of a workload for my system. It might hang for a very long time. Guys can go check that on my this one. I think all the notebook, whatever I explained, still works the same way in the ML notebooks as well. So you guys can go check that out. And for a while, I think I can Azure Cognitive Services. What is that? Azure Cognitive Services Visuals dot web dot app. I think Cognitive Services Visuals. I think Cognitive Services Visuals. Hey, wait, I can't share my WhatsApp, so sorry for that. I think so. Wait, it's React. Hmm. Wait, I've shared so many links and I've created so many websites. I've forgotten the links and everything. Like, oh God, what's wrong with this? God, my phone will always be on edge. Now I'm turning it on. So sorry for that. Man, so much of things. I think Atira.
Sir, are we done?
Nay, nay, bro, don't worry. Nay, no. I'm just opening a notebook for this one. So
Okay,
my
okay, no issues.
I think I can share you a new experiment in this ML. So don't worry about that. I think I can share you a new one. So wait, I think there are different ways in which you can deploy it on a designer, right? So whatever I showed you is just for a notebook sake, but this is a Databricks thing, but still works the same way in terms of your notebooks as well. So you guys can go check that out in the notebook section. Also, if you don't worry, I am ready to even teach you for other 50 hours. So let me just do one thing. I'll just teach you all that notebooks as well. So notebooks are here. So I just cloned an image classification MNest. It's a simple thing. I think already the runs have already been completed, but worst part I need to do all this. I think better just do the same notebook. What you guys can do is you can just click on all these different links and every environment that you're just doing right now will just follow the same old syntaxes in ML flow. So just go ahead and just do that. Wait, I just want to just put on my this one. That's the thing. So I just need that link to come up. That's it. I'll always be in the edge in my phone charge. So it's 9% now. So I'm just taking it. All right, where is that? So wait. Reactor. Oh, days. Wait. wait. All right. All right. This is the one. So I can share my screen now. I'll share my screen now. Yep. This is the one. So this is a website that I wrote for the Azure Cognitive Services. You guys can go check that out. So it's an end-to-end solution that I have given, right? It's like using Python. Computer vision was taken care here, and of course you can go and click on the computer vision here. You'll get all the different notebooks and everything about your text was taken care, and your text now you're welcome. You're now welcome to the text now tree centric solution. Everything that was taken as an image here was now being taken care right now. And this is the best part about it, right? What's it all about the Hawaii? It got to know that II is like the exclamation mark and everything. Of course, there are different APIs that I've already worked on. Face APIs are already being created. It knows, okay, I'm going to change my face YouTube DP. Like, I need to get them sorted. So, okay, like, different APIs were being considered. Everything that was supposed to be done as an end-to-end solution is already being taken care here. So you guys can check this notebook as well as different text analytics also was taken care. So if you are an NLP person, you can still use all these things. You'll start working on all these. Of course, translator was already taken care here. So translating the text was already taken. Speech to text was already taken. Text to speech was already taken care here. So it just works seamlessly for you folks. So you guys can check out any amount of cognitive services. Of course, I'll be uploading some more notebooks, some more demos on this website. So keep following this entire infrastructure that I just built for you using some code and some samples here. I think that's it from my side, folks. Thank you so much for taking part of it that time. And also, I just became late today. Sorry for that because personal work. So I had to go out there. And perfect, folks. Thank you so much for being part of this show. And thank you, Supriya, for hosting me.
Yeah, it really went great, and I really hope this will helpful for the people who are interested with the Azure with ML. So, so whoever interested to join in our or community, Varangal community, you can find the link in the chat box. I mean comments.
Sure,
Okay,
I think. Thank you so much, folks.
Vishwas, we definitely come up with
I'll
other.
come up with some more things because to be
Yeah.
very frank with you, like I'll say what happens with my every single day. It's like very random. Anybody can call me at any one point and they can say me the work. But the problem with me is I get too indulged in the work. And that's the problem, I think.
Okay, that's
And
okay. But we
that's
definitely
okay.
try to get with other
Uh,
sessions soon.
Thank you so much. Thank you so much, folks. And I think
Yeah.
let's just move on with the other advanced session that I will be planning for. I'll come completely prepared for other sessions. Don't worry about that.
And be on time.
Yeah, and be on time. Yes, for sure.
Yeah.
And thank you so much, folks. Thank you so
Thank you
much.
guys. Thank you,
Bye.
Vishwas. Bye.